talk about how to factor trinomials with grouping. We've talked about factoring by grouping, where you have four terms. So you take the middle term and you split it here, and I factor the two halves. So out of this left half, out of 3x squared plus 6x, I can pull out of 3x, and I'm left with x plus 2. And out of the right half, negative 2x minus 4, I can pull out a negative 2, and I'm left with x plus 2. And since these bubbles here are the same, I can take the stuff in front of it, the 3x and the negative 2, and combine it. And the x plus 2's also become a bubble, and that's how that factors. Well, what a lot of people have seen or discussed, or hopefully realized, if you're able to factor 3x squared plus 6x minus 2x minus 4, if you're able to factor this, then it really means you're able to factor this, 3x squared plus 4x minus 4. We can do that by grouping also, because I can just take the 6x and the negative 2x and put them together. So if I started with a problem that looked like this, if I could make this expression look like this one, I'd be able to factor it. And that's the real challenge. The question is, how can we split up that middle term into two things that we know can factor? So here's a new problem, 2x squared plus 11x plus 15. I want to somehow write this into, 11x is really 9x and 2x. So maybe I want to do something like this that will give me something that I can factor. The issue is, how do you split it up? There's an infinite number of ways to split up 11x into different things. So there's kind of this method that you can follow that you've sort of seen before, but kind of not. If I take the a term and the c term, 2 and 15, and I multiply them, and I get 30. If I can find two numbers that multiply to 30, but add to 11, that's how I split up my factors. So if I think about the factors of 30, 30 and 1, 15 and 2, 10 and 3, 4 doesn't work, but 5 does, 6 and 5, those are all the numbers that multiply to 30. And this pair here, 6 plus 5, that pair adds to 11. So that means I can take this 11x and really split it up into a 6x and a 5x. And the 2x squared and the 15 don't change. Now I've taken a trinomial, turned it into an expression with four terms, and I can factor it. Here on the left side, I pull out a 2x, plus here, and I have x plus 3. On the right side, I pull out a 5, and I have x plus 3. So I have 2x plus 5 times x plus 3. And this is called factoring a trinomial by grouping. Some of you have been asking for a method that isn't just guess and check, and this is really the best one, factor by grouping. I'll do another example. I'm going to go through it kind of quickly, but you can just see it done one more time. I do 4 times 12, which is 48. So I write out the factors of 48. You want to do this in as organized a fashion as you can. So 48 divided by 3 is 16. 48 divided by 4 is 12. 48 can't divide by 5. 48 divided by 6 is 13. No, 8. Come on, Rand. And 48 can't divide by 7. Well, I want these to add up to negative 19, so these are all really going to be negatives. The pair that adds up to negative 19 is this one right here. Negative 16 plus negative 3 is negative 19. Now I can put that 16 and that 3 on either side. I mean, the 4x squared doesn't change, and the positive 12 doesn't change. I can put minus 16x and minus 3x like this, or I can put minus 16x and minus 3x like this. I can do it whichever way I like. I actually like it the first way better. I like having the minus 16x first, because then both my halves factor really nicely. It doesn't actually matter which way you do it. Either way it'll work out the same. But I'm going to do it here. So split it there. I can pull a 4x out of this, then I'm left with x minus 4. I can pull a negative 3 out of this, and left with x minus 4. So it's 4x minus 3 times x minus 4. And there's my factors. One more. Here's the last one I'm going to do. I've actually written down the steps over on the side. There's really a lot of steps. Writing out the steps is kind of tough to do. I'm going to try and follow the steps here so you can see it done with the steps. The first step, I really call it step 0, because everything should always, whenever you're factoring, should always plot a GCF first. Here I can pull out a 2. I'm left with 9x squared plus 21x plus 10. always pull up that GCF first. That was step 0. Step 1 is to multiply A and C. Well, 2 times 10, I'm sorry, 9 times 10. My A value is now 9. This 2 here doesn't do anything. It's not going to have any impact on anything from here on out, but you can't get rid of it because we don't have an equation. So I multiply 9 and 10 for step 1, and that gives me 90. Step 2, write out all the factors of 90. Four is not going to work, 5 is going to work, 5 goes into 90 18 times. 6 going to work, yep, 6 and 15. 7 is not going to work, 8 is not going to work, so I have 9 and 10. Now, because this was a positive and these are positives, these can all be positives, everything's positive. I find the pair that adds up to 21. That's what step 3 is. My B term is 21. I want to find a pair of numbers that add up to 21, and that's 15 and 6. Step 4, replace the B term with the 2 factors from step 3. This is the one that most people get confused on. You can't go straight into bubbles. I'm actually going to go here. The idea is 21x is really the same as 6 plus 15, but nothing else changes. A lot of people at this point try to go straight into bubbles. You can't do that. Split this in the middle. My 2 still just sits out there. So I actually have to put this in brackets now, just to break out the parentheses in the brackets. It doesn't really matter, but that's what I do. Here, out of this left half, I can pull out a 3x, and I'm left with 3x plus 2. Out of the right half, I can pull out a 5, and I'm left with 3x plus 2. So now I combine things, so I have 2 times 3x plus 5 times 3x plus 2. That's how that factor. Now that would not have been an easy factor to do by guessing checks. Certainly possible, not too tough, but probably not easy for a lot of you. And there I kind of just ran through the steps of grouping in a hurry, 5, 6, 7. Now, just so we're clear, if you write out all the factors and you can't add up to your B term, say my B term was 22. If my B term was 22x, none of these things add up to 22. So that would mean it can't factor. You can tell very clearly if it can't factor, and that's sort of nice. You just have a result that can't happen, you say you can't factor, it's prime, and you're done. You don't have to worry about missing combinations or missing possibilities. That's factor by grouping. That's all we had for today. Hope you find this helpful.